Types of MCBs. The MCBs are classified by the number of poles. Here poles refer to switches. A single pole has a single switch. A two-pole has two switches. Likewise, a single pole circuit breaker protects a single phase of the circuit and has only one switch. A double pole circuit breaker has two switches and also protects a phase and neutral. A three-pole circuit breaker has three switches and they also protect the three phases. A four-pole MCB contains four switches, three phases and a neutral. The four poles protect all three phases and the neutral. Current ratings of MCB. The value of the current over which the breaker trips is known as the current rating. The rated current of the MCB to be used depends on the load current of the equipment to be protected. This value ranges from 6 to 125 amperes for a standard MCB. They come in the following ratings: 6 amperes, 10 amperes, 60 amperes, 20 amperes, 25 amperes, 32 amperes, 45 amperes, 50 amperes, 63 amperes, 80 amperes, 100 amperes and 125 amperes. For instance, it is advised to install a 20 amp MCB if your home has air conditioning, while 6 amps should be plenty for standard lights and fans. How to install an MCB? Calculate the current rating of the load that has to be connected to the MCB. Choose the MCB with the appropriate current rating for the load. If the load current is 4 amps, choose the MCB for 6 amps. If the load current is 6 amps, choose the 10 amp MCB. Always prefer the 2 and 4 poles for single and 3-phase circuits respectively. Check the MCB manually by switching on and off the knob. Ensure the knob falls quickly when pulling it down. Choose the location to mount the MCB. MCB should always be installed inside a metal paneled enclosure. Mount the metal box on the wall with the appropriate screws. Fix the MCB end clamp or C-clamp inside the metal box. Mount the MCB by pressing firmly against the bar in order to be attached. Make sure the MCB is fixed in the correct position so that you can switch it on by lifting the knob upwards. Loosen the screws at the terminals of the input and output sides of the MCB. Connect the supply wires to the MCB's input terminals and the load to be protected to the MCB's output side. Switch on the power supply by lifting the MCB knob upwards and ensuring the load is working without any interruption. Take a 1 foot length of half square millimeter wire. Remove the insulation on both sides of the wire. Holding on the insulation part, place the bared part of wire between phase and neutral for rapid seconds and nothing but making a short circuit. At the instant, the MCB will trip and disconnect the power supply to the load. By switching off the MCB, you can now apply a load greater than the MCB's ampere rating. Nothing but overloading. When you try to switch on the MCB, the knob will not sustain in the on position. The knob falls down continuously because of overload current. Let us discuss on ElCB. ElCB stands for Earth Leakage Circuit Breaker. Like MCB, ElCB is also a switch, but it protects against earth leakage. An earth leakage circuit breaker is a type of circuit breaker that is used for protection against leakage current. When it detects the leakage current, it disconnects the load from the power supply. The earth leakage can cause electrical shocks that can be fatal. Simply, the primary purpose of an ElCB, a safety device, is to guard against electrical shock. It keeps track of the leakage current that escapes from the circuit via any unauthorized route. But it cannot protect against overloading or short circuit current. RCCB, or residual current circuit breaker, is another name for ElCB. What is meant by earth leakage? There are many different causes for earth leakage. It may happen as a result of conductors that are broken or live conductor insulation that is damaged. Additionally, it could happen if the live conductor makes touch with the equipment's body. When a human touches a conductor or piece of equipment, the current can travel through the body and out to the earth. This leakage current or a useless current can cause an electrical shock if the equipment is not properly earthed. For example, the outer body of the motor is made up of steel, which protects the internal wiring from the atmospheric conditions. Strong insulation will also be provided between the winding and the motor housing. Sometimes in aged motor, the insulation may fail or becomes weaker. During this time, a current flowing in the winding may also cause flow in the housing of the motor. This may cause an electric shock to the person when he or she touches the motor body. If the motor is properly earthed, the leakage current will flow to the earth and he or she will be safe. If you connect the motor with the ElCB, it will trip or turn off the circuit automatically unless you rectify the insulation failure in the motor or replace the motor with a good one. This problem also occurs in electric irons usually. Generally, an ElCB is designed to trip or turn off the circuit for a leakage current of 30 milliamperes. Let us discuss with an example. Let us assume a motor is connected with an ElCB and draws 5 amps from the main supply, which means the motor takes 5 amps from phase return back through neutral. If the motor has proper insulation, it draws 5 amps from phase and returns the same 5 amps back to supply through neutral. The ElCB will remain in the on position since there is no difference between the current in phase and neutral. Suppose the motor insulation fails and draws some leakage current to its housing. It may be 40 milliamps. Now the motor will draw 5.04 amps of current from the mains, in that the outer body of the motor takes 40 milliamps and the remaining 5 amps back to the neutral. Here, a current difference exists between phase and neutral with 40 milliamps. These 40 milliamps are enough for the ElCB to trip or turn off the power supply from the circuit. Let us discuss how to select ElCB. Like MCB, ElCB is also available for single-phase and three-phase circuits like 2-pole and 4 poles respectively. ElCB current rating selection is similar to MCB except for the tripling of current sensitivity. The ElCB has several tripping sensitivity levels, including 30 mA, 100 mA, and 300 mA. To protect against the electrical hazards to human safety, we must choose 30 milliampere as the sensitivity, and to protect the electrical hazards against electrical equipment, we can choose the sensitivity of 300 milliampere. Let us discuss how to connect the ElCB. The ElCB mounting or fixing procedure is the same as for the MCB. In any circuit, the ElCB is connected between the MCB and the load. The MCB is always connected first because if there is any fault occurrence between the ElCB and the MCB, when the ElCB is connected first, the MCB cannot protect the ElCB and the circuit may be damaged. The ElCB has two current ratings. One, rated current such as 16 amperes, 20 amperes and up to 125 amperes, and 2, rated in current sensitivity such as 30 milliampere, 100 milliampere and 300 milliampere. The rated current indicates that the ElCB can withstand up to this rating current. For example, a 20 amp ElCB can withstand a 20 amp current. That means when there is more than a 20 amp current flowing through it, it will be damaged. Suppose an ElCB has a rating of 100 milliampere. That means when 100 or more than 100 mA of leakage current occurs, the ElCB will trip. So always select the rated current of the ElCB greater than the MCB's current rating. For example, if you use a 20 amp MCB, then you must use an ElCB of more than 20 amp rated current rating. If you use an ElCB with a current rating lower than the MCB's current rating, then the ElCB will be damaged. Let us assume you have 6 sub-circuits. Each sub-circuit is protected with 6 amp single-pole MCB. So you have to install a common MCB at main distribution side for 36 amps of 2-pole MCB. Then you have connect ElCB in between the main MCB and sub-circuit MCBs not less than 36 amps of current rating and sensitivity as 30 milliamps. From this video session, I hope you will be able to apply or connect the fuse, MCB and ElCB to an electrical circuit and protect it. Thank you for watching. Have a good day.